Welcome to Rges Pre-Algebra Lesson 15B. We'll be discussing sections 4.27 through 4.29. Now, 4.27 has to do with dividing sine numbers. We'll actually skip over 4.28 for now. We'll come back to that later when we pick up more algebra concepts. And we'll be going to 4.29, using sine numbers to combine like terms. So let's go ahead and review our multiplication. How do we multiply sine numbers? And recall that this is a very simple rule, much easier actually than adding and subtracting. To multiply sine numbers, you are just considering if you have a positive times a positive, or you equal a positive. If you have a positive times a negative, or a negative times a positive, because we can reverse the order with multiplication, meaning 2 times 3 is the same as 3 times 2, so it doesn't matter which one comes first, the positive or the negative. You'll have a negative, and if you have two negatives, negative times negative, it equals a positive. We can also, we're talking about multiplying sine numbers. We can also think about it this way. If the signs are the same, both positive or both negative, then you will have a positive. And if the signs are different, either a positive times a negative or a negative times a positive, then your answer will be negative. Now we also expand that, because we could do it in groups of pairs, to think of an even number of negatives. They will each cancel out, negative times negative to equal a positive. So if you have a lot of numbers strung together and you have an even number of negative ones, the answer will be positive. But if you have an odd number of negatives, the answer will be negative. And once you've learned those rules, these are the rules stated in a couple of different ways. Once you have learned these, you know the rules for division, because a division is just the multiplication of the inverse. So recall that to divide is to multiply by the inverse. So all my sine rules will be the same. Rules for sines, whether it's positive or negative, will be the same as multiplication. So that's pretty easy. Now let's give you some examples so that we can practice this idea. Let's go through these quickly. We have a positive divided by a negative. The signs are different. Our answer will be negative. And 14 divided by 2 is 7. We have a negative divided by a negative. The signs are the same. It will be positive. We could write it or not. 25 divided by 5 is 5. So I could either write it that way or simply just write the 5. A negative divided by a positive is a negative, and 18 divided by 3 is 6, and that's all there is to it. And that's lesson 4.27, and you'll also be doing several sharpening skills, which is just review with adding and subtracting, multiplying, and dividing sine numbers. Now let's, on the next page, go to our new idea. Now recall that when we are combining like terms, we will only add together the ones that have the same variables to the same exponents. So those combine and those combine. 7x minus 3x leaves me with 4x, and 2y plus 8y leaves me with 10y. Now what will happen if we start having negative and positive variables? Let's see. So in this next example, these are like terms, so we want to think negative 6 plus 4. Well, these are opposite. We're thinking on our number line from 0. we're going this way, 6, and then back 4. So we're going to end up on the negative side, and the difference between the 6 in this direction and the 4 in this direction will leave me with 2. So negative 2, but don't forget your variables, negative 2x. Let's look at more what we would be inclined to see as a string of numbers being combined together. So let's give you one like that. Okay, our next example, we want to identify all our like terms. Our x squareds are going to be this way, and our xy's are going to be this way. Now, I think the easiest thing to do is look, when you have more than 2, you look at, as you do in your x squared terms, I'm going to combine the positives together and the negatives together, and then I'm going to take my subtraction. So 9 plus 4 is 13x squared minus 6x squared, which gives me 7x squared. And 4 minus 3 gives me 1xy. Now, you don't have to write this step in, but mentally I would gather up the like terms, the ones that have the same sign first, because typically we're more accurate with addition than we are with subtraction. So let me give you one more example like that. So I would be inclined, again, if I'm got a whole string, I'm looking for my x terms. And I've got one positive and negative 7 minus 9. We're going to add those together because they're going both in the same direction to the left. So that will give me negative 16. So I'm gathering my x terms first. And then for my y's, I'm going to look, I've got 2 positives and 1 negative. You could or could not write those write this line, or you could just do this mentally, but I would be inclined to write it when you're getting a whole group together while you're first learning. Then I'm going to combine my x's. Recall they're in the opposite direction. I add 3, then I subtract 16. So I'm going to be negative. The difference is 13x. And 5 minus 4 is 1y. Go ahead and look at your sharpening skills for the word problems, and do not look on the next page until after you have tried to solve those 4. And so the next page will be a hint if you need help doing those word problems. The first one says, separate the number 38 into 3 parts so that the second number is 2 less than the first number, which is 1/2 of the third number. So for these, separating them into parts, I think of some kind of length divided into 3 parts, not even, of course, but I'm just writing them anyway, just reminding me the whole thing is 38. If the first one's x, the second part would be what? X 2 less than x, or x minus 2. And it says the first number is half the third. So if the first one is x, the third part would be 2x. So now hopefully you can see that the equation would be the first part plus the second part plus the third part all equals 38. So I think you can do the rest of that. Number 2, it says Mrs. Gonzalez spent $58 on groceries. She had $13 left after paying for the food. How much money did she have before? So she's got a certain amount of money, and she subtracts 58, and she has $13 left. That's pretty straightforward. Number 3, so go ahead and solve that. It says the Mount Vernon Christian High basketball team played 24 games during the basketball season. They won 4 more than they lost. So again, we could almost look at this as this way. Altogether, they played 24 games, and then we have a certain amount won and a certain amount lost. It says they won 4 more than they lost. So if this is what they lost, and this is what they won 4 more than they lost. So if this is x plus 4. How would you set up your equation? You would add the number lost, that's like your first group, plus your number won, and altogether that equals the number played. And finally, your hint on the last problem, the combined ages of Megan and Kyle are 27. If Kyle is twice as old as Megan, well, you see we can do this one the same way. Combined together, we have 27. We have Megan, and we have Kyle. And it says Kyle is twice as old as Megan. So if Megan is x, then Kyle is 2 times x. You can hopefully see this equation now. You combine those together, you get x plus 2x altogether equals 27. So this is a good way to visualize word problems like this. And have a good time doing it, and bring your questions next week.